In this video, we are going to discuss about silicon control rectifier, that is SCR. SCR belongs to the thyristor family. It is a 4-layer 3-terminal device. The 4 layers are P, N, P, N. These are the 4 layers and 3 terminals are anode, cathode and gate. This is the symbol of SCR and this is the structure of SCR and this is the simplified structure of SCR. In the structure of SCR, this P plus and P layer forms the anode and N minus layer absorbs depletion layer of the junction J2 and this P layer forms the gate. This N plus layer forms the cathode and it is having 3 junctions J1, J2, J3. Static characteristics of SCR. In static characteristics, the anode to cathode current is plotted with respect to anode to cathode voltage. So here in the picture you can see x-axis is VAK, anode to cathode voltage, y-axis is anode to cathode current, that is IAK. And here you can see 3 modes of operation. One is reverse blocking mode and the second one is forward blocking mode and the third one is forward conduction mode. In the reverse blocking mode, the SCR is reverse biased. That means P2 negative, N2 positive. So reverse biased condition. And during this state, the SCR won't conduct, but there will be a small leakage current flowing through the SCR, and that current is called as reverse leakage current. And VBR is the reverse breakdown voltage. And when the SCR is moved beyond this reverse breakdown voltage, the SCR conducts and the SCR will be damaged. So the SCR should not be operated above this voltage, that is reverse breakdown voltage. If it is operated above this voltage, the SCR will be damaged. And the second one is forward blocking state. This forward blocking state means the SCR is forward biased, that is P2 positive, N2 negative. And during this stage, a small leakage current flows through the SCR and that leakage current is called as forward leakage current. And VBO is the forward breakover voltage. That means when this voltage is reached, the SCR automatically turns on and without any gate signal. And the SCR can be turned on before this voltage, that is by giving gate voltage. IG1 is the gate current, IG2 is the gate current 2, IG3 is the gate current 3. So higher the gate current, shorter is the on time. So you can see here IG1 is lower and it takes some time to turn on, whereas IG3 is the gate current 3, which is higher gate current, and it takes short time to turn on. Okay, so this is the forward conduction state and this drop is called on state voltage drop, because at this stage the SCR will be turned on and this voltage is the on state voltage drop. The working of SCR shall be discussed in 3 modes, that is reverse blocking mode, forward conduction mode, which we have discussed earlier. Reverse blocking mode means the SCR is reverse biased. Forward blocking mode is the SCR is forward biased but the gate signal is not given. Forward conduction mode means it is operated either at above VBO or the gate signal is given. During reverse blocking mode, the SCR is reverse biased. Reverse biased means P2 negative, N2 positive. That is, anode is made negative with respect to cathode. Cathode is given positive. Due to this reverse bias, junction J1 and J3 are reverse biased. So J1 and J3 are reverse biased and there won't be any conduction at this junction. And only J2 is forward biased. And due to this, very small leakage current flows through this SCR and that current is called as reverse leakage current. And at reverse breakdown voltage, the reverse current increases rapidly and the SCR is damaged. Therefore, the SCR should not be operated at the reverse breakdown voltage or over the reverse breakdown voltage. During forward blocking mode, the SCR is forward biased, that is P to positive, N to negative. The anode is connected to positive and the cathode is connected to negative. And due to this forward bias, junction J1 and J3 are forward biased and junction J2 is reverse biased. And during the time this PN junction conducts, this PN junction conducts, and only here the depletion region will be formed. Okay, and a very small amount of current flows from anode to cathode, and that current is called as forward leakage current. The voltage VAK can be increased till forward breakover voltage, and above the breakover voltage the SCR turns on. So the SCR comes to on state when VAK is greater than VBO. And or if you want to turn on the SCR before the breakover voltage, you have to give positive supply to the gate. By means of giving gate pulse, the SCR can be turned on before VBO. Forward conduction mode. It is the mode when the SCR is turned on. So here, when the SCR is forward biased, it can go to forward conduction mode by any of the following techniques. That is, the first technique is when VAK is greater than VBO, which we have discussed in the previous slide. VAK is the anode to cathode voltage. When the anode to cathode voltage is greater than breakover voltage, the SCR is in conduction mode, that is, it is turned on. Second one, when gate drive is applied. So even before the VBO, when you apply gate drive or gate pulse, it can go to on state. It can go to conduction state or on state. Third one is when dV by dt exceeds permissible value. That is dV by dt in the sense the difference in voltage should be very fast. When the difference in voltage is very fast, it can turn on the SCR. Then last one is when the gate cathode junction is exposed to light. So this is gate and this is cathode. When the junction J3 is exposed to light, there is a possibility of turning on the SCR. Latching current and holding current. Latching current. The minimum forward current or anode current above which the SCR turns on is called latching current. Here in this picture you can see the IL is the latching current, and you can see the arrow mark, it is moving upwards. That means it is in the forward conduction mode, and IL is the minimum current and above which the SCR turns on. Right, next one is the holding current. So it is the minimum forward current or anode current below which the SCR turns off. Here you can see the arrow, it is downwards. That means if it goes below this point, then the SCR is turned off. And normally the latching current will be in the range of 10 to 15 milliamps. The holding current will be in the range of 8 to 10 milliamps. Switching characteristics of SCR. The time variation of voltage and current during turn on and turn off process gives the switching characteristics of SCR. This switching characteristics is also called as dynamic characteristics of SCR or transient characteristics of SCR. When the positive gate voltage is applied to the SCR, the SCR will comes to on state. This transition time is called turn on time. So bringing the SCR from off state to on state is the SCR turn on time, and that SCR turn on time is equal to delay time plus rise time plus spread time, that is TD plus TR plus TP. In this diagram, you can notice the variation of current and voltage of SCR with respect to time. And here is the anode current, which varies with respect to time, and this is the voltage, that is anode to cathode voltage with respect to time, and this is the gate drive. When the gate drive is applied, the SCR moves from off state to on state, and here you can notice this is the point at which the gate drive is applied, and this is the delay time, and this is the rise time, this is the spread time. So the total time taken for the SCR to turn on is equal to the addition of delay time, rise time and spread time. So delay time is the time at which the anode current rises slowly. But you can see the voltage, there is no drop in the voltage, it remains same. And the next one is the rise time. During rise time, the anode current increases rapidly, and at the same time, the anode to cathode voltage decreases rapidly. So during delay time, the current increases, voltage decreases. And the third one is the spread time. During spread time, the current reaches the maximum value and the voltage reaches the minimum value. And here you can notice that there is anode to cathode voltage drop during on state. So during the switching time, the power dissipation will happen and it is called the switching loss. This is the explanation for the figure. So during delay time, the anode current rises slowly and the voltage does not reduce. During rise time, anode current increases rapidly and the voltage falls rapidly. And during spread time, the current reaches the maximum value and the voltage reaches the lowest value. So the total time taken for the SCR to turn on is equal to the addition of delay time, rise time and spread time. Switching characteristics of SCR during turn off process. So the SCR doesn't turn off by itself or by removing the gate. The SCR needs an external circuit to turn off. This external circuit is called as commutation circuit. So we need an external circuit to bring the SCR below the holding current. Okay, the process of SCR from conduction state to forward blocking state is called commutation process. That is, simply we can say the process of SCR from on state to off state is called commutation process or turn off process of SCR. So we are going to bring the SCR from on state to off state. So the total time taken for the SCR to bring to off state is the addition of reverse recovery time and gate recovery time. That is TRR plus TGR. So in this picture you can notice that the SCR turn off process is the addition of reverse recovery time and the gate recovery time. So the sum of reverse recovery time and the gate recovery time is called as the total turn off time. And during this reverse recovery time, the anode current reaches zero and it goes negative. It goes negative because during the conduction state, the SCR is flooded with charge carriers. There are many charge carriers and it takes some time to remove all the charge carriers. Therefore, the anode current is negative. So at the end of reverse recovery time, the anode current reaches zero. That means all the charge carriers are removed and the voltage becomes negative. This negative voltage should exist for some more time and that time is called as gate recovery time to completely turn off the SCR. If it is not maintained in the negative voltage, um, it may turn on at any time. So at the end of gate recovery time, the SCR is completely turned off. So this is the explanation for the switching characteristics of SCR during turn-off process. At the end of reverse recovery time, the reverse voltage appears across the SCR and the current becomes zero. So at the end of reverse recovery time, the SCR is not turned off. The negative voltage across the SCR should be maintained for the full gate recovery time. Otherwise, the SCR may be turned on due to excess carrier near junction J2. Hence, the turn-off process is completed at the end of gate recovery time. Therefore, the total turn-off time is equal to reverse recovery time plus gate recovery time. Inverter grade SCR and converter grade SCR. Inverter grade SCR is the SCR which have turn off time less than 25 microseconds are called inverter grade SCR. If the turn off time is greater than 25 microseconds, then it is called converter grade SCR. Inverter grade SCRs are used in inverters, choppers, etc. Converter grade SCRs are used in rectifiers, AC voltage controllers, etc.